Hey everybody, this is Mrs. Kalanicki. Just a quick reminder before I start this video, there was homework due yesterday and I am checking. So if you did not complete number 67 that was due Thursday, there was an email that was sent out to your parents, so be aware of that. And number 68, parts A and B are due Tuesday, so that's just a reminder to you. Make sure you write those down. Those were on the board, or they will be on the board. All right, so now moving on to today. Today's lesson is experimental versus theoretical probability, and this is page 6 if you're on the right page. All right, so we've kind of already talked about these two terms twice so far. Once with your Skittles activity and once during activity 10.1, which was our first lesson in our new packet. So we're talking about an experiment, which is when we do a probability. We find a probability based on what has happened in an experiment. So it's probability that is based on repeated trials of an experiment. So obviously when I do an experiment, and I don't mean necessarily a science experiment, I just mean like I'm doing something multiple times. I'm rolling the dice 10 times. I'm picking a tangram 10 times. I'm spinning a spinner 20 times. I am flipping a coin 30 times. That's based on an experiment. Theoretical probability is when everything is fair. I haven't done anything yet. I'm holding a die and I want to know what's the chance of me getting, a 2. That's based on the event that I have in my hand or that I haven't done yet. In one time, in that one spin, in that one flip of my coin, in that one roll of my dice, what's the chance of that thing happening that I want to happen? And again, we use the word favorable, but again, it's things that you want to happen over the total number of possible outcomes or total number of things that could happen. And if you see, when you look at the experimental, it's the number of times it did happen in that experiment. The number of times you did the experiment, the number of trials. How many times did you try this experiment? So let's look at this little kind of example on the side. So I have Jake rolls a die 20 times and the results are shown in the chart below. So take a look at the die. So he got a 1 4 times, number of times. He got a 2 5 times. He got a 3 2 times. How many times did he get a 4? He got a 4 2 times. How many times did he get a 6? 2 times. Okay. So now, what is the experimental probability that Jake rolled a 6? So when you see the words experimental probability, you need to look at, and I'm going to type it and I want you to write it, look at the table or chart. Look at table or chart. I'm going to have to squeeze it in real good because it's going to fit right over here. I'm just going to try to make it fit. Let's see if it'll fit. Make it real small. Very small. But I'm going to squeeze it in right here. Look at the table or chart that is given to you. So based on this chart, how many times did Jake roll a 6? Okay, according to this, he rolled a 6 2 times. So 2 is the number of times that he rolled a 6. Out of how many times did he do this experiment? How many times did he roll a die? Well, up here it says he rolled it 20 times. If I didn't have this number, another way to find out 20 times is I would have to add all of these numbers up to figure out that he rolled it 20 times. Okay, so my experimental probability that Jake rolled a 6 is 2 out of the 20 times that he did the experiment. Okay. Another question you could be asked, and I could give you the same information, is what is the theoretical probability that he rolled a 6? Again, this time, I'm not looking at the chart at all. I'm thinking about what do I know before I even rolled the die. All I know, this is based on what I know about a die. So I'm going to write this in the little words, based on facts. What do you know about a die? Based on the facts that you're given about a die, you know that a die has 6 numbers and it has 6 equal sides. That's all you know. And that's all you're basing your theoretical probability on. It's based on what you know about a die. What's my chance that Jake would roll a 6? Okay, well, how many 6s are on this die? 1. That's it. There's only 1 6 on this die. And out of how many possible options? 6. There's 1 6 on the die out of 6 possible sides. You see how these two are very different from each other. Experimental is based on the experiment. So either they're going to ask you to do an experiment, or most likely, just because everyone's going to get the same answer, I'm going to give you some results of an experiment that was already done. So you have to look at what's here to base your answer on this chart. If they ask you for theoretical probability, think about what we did before. Here's a spinner. What's my chance of getting a 2? What's my chance of getting a 3? What's my chance of getting a red? What's my chance of getting a blue? You're basing it on just what you're given to start with, based on the facts of a die. What's my chance of getting a 6? That's it. All right, so let's go on to some more practice questions. Lena rolled a number cube or a die a few times and recorded her data in the bar graph below. So let's take a look at this so we can understand what this is talking about. Rolling a number cube, the number rolled, so here are her numbers. She could have rolled a 1, a 2, a 3, a 4, a 5, or a 6. And this is the number of times she rolled them. So again, make sure you understand what this is. So this 48 means she rolled a 1 48 times. She rolled a 2 53 times. She rolled a 3 50 times. She rolled a 4 52 times. A 5 49 times. And a 6 48 times. Okay. What is the experimental probability of rolling a 2? So based on this experiment, how many times did she roll a 2? She rolled a 2 53 times. Well, that's great, but out of how many? It didn't say. It didn't say how many times she rolled it. So my job now is to figure out, well, how many times did she roll it? Well, here's how many times she rolled a 1, how many times she rolled a 2, a 3, a 4, a 5, a 6. So what I'm going to have to do is I'm going to have to add the times rolled. Or you could show me that you're adding 48 plus 53 plus 50 plus 52 plus 49 plus 48. Tell me what that is. What's the total number of rolls? Pause the video. Figure it out. Do it. Don't watch math happen. Do it with us. Okay, hopefully you did it, or you're pausing the video. You paused it and now you're back. You should have gotten, I believe, the total is 300. And again, this is a good time, especially when you're using a calculator to add a lot of numbers, so to go back and look at this screen and make sure all the numbers are correct before you add them, or add them twice to make sure you get the right number. So my experimental probability of rolling a 2 is 53 twos out of 300 rolls total. All right, second question. What is the, again, experimental probability? So again, I'm basing it on what information I have here, on rolling a 3 or a 5. So again, I would be happy getting a 3, and I would be happy rolling a 5. So what I'm going to have to do is I'm going to have to put those two together. I would be happy with the 3, I would be happy with the 5, and together that makes 99 things I would be happy with getting. Out of, again, my experiment, I did my experiment 300 times. So rolling a 3 or a 5, I would be happy with either one. So I'm going to put them together. 99 out of, again, 300. Now, the third question is a little different. What is the theoretical probability of rolling a 6? Again, that means I do not look at this. That means I think about a die. In theory, I'm pointing to my brain. In theory, what's my chance of getting a 6 when I roll this die one time? That's it. A one-time event. So rolling a 6, there is how many 6s on this die? 1. Out of how many possible sides that could have rolled? 6. And that's it. So you see the difference between the experiment, me looking at a chart or a graph for information, based on theoretical probability where I just think about the situation in my head. I look at a die and I say, okay, if I had to roll it one time, what would happen? If I flipped a coin one time, what would happen? If I spun a spinner one time, what would happen? Okay, so I want you to flip over. There's another one here. I want you to do this one by yourself. Pause the video. Do numbers 1 through 4 based on the graph that you're given. My hints for you before you start is to take some time to look at the graph, maybe even write the numbers on top, because if you notice on the last one, that was pretty helpful to have the numbers there. So you may want the numbers there also. So put them there. And again, you may want to find the total at the beginning too, so you don't have to do it later on. All right, pause the video, come back when you're ready to rock and roll. All right, so hopefully you're back. So here's what I did to set myself up for success. I started with numbering how many were on each one. So I got green 4 times, I got yellow 2 times, I got orange 3 times, and I got purple 1 time. So I was doing something. It looks like I was drawing a marble. So I was picking a marble out of a bag. I don't know anything about the marbles. I don't know how many colors there were. I'm thinking there were probably a lot of red in the bag and then probably not a lot of purple in the bag. That's what I'm thinking based on this graph. But I don't really know because they didn't tell me anything about the marbles that were in the bag. So it says use the bar graph to find the experimental probability. So I'm only looking at this to figure out what probability I have. All right, so drawing a red. So I see that there are 6 reds out of, oh, I forgot to do this part. 6 plus 4, plus 4, plus 2, plus 3, plus 1. You should have gotten a total of 20. So my fraction is 6 out of 20. You could reduce it. Your calculator will reduce it if you put it in there. You could make it into a fraction, into a decimal, into a percent. We're just going to leave it as fractions for today. But again, be sure that if I get a multiple choice question and 6 out of 20 isn't there, you may want to reduce it. Oh, but 3/10 is there. Oh, so that's the same thing. So this is going to be my choice. So be aware of that when you have a question like this. If your answer is not there, it might not mean you're wrong. It just means that your answer might be either in reduced form or it could be in as a decimal or as a percent. So be aware of that. All right, drawing an orange. So again, here's my orange. Since I did all this work ahead of time, writing the numbers, writing the total, 3 out of 20. 3 oranges out of 20 total picks. Not drawing a yellow. So here is my favorite trick for doing this. What I could do is I could add up all the not yellows. So I would add up 4 and 6 and 4 and 3 and 1. And that gets me, what is that, 18. 18 out of 20, which are all the ones that are not yellow. And that's one way to do it. And this is totally the right answer. Another way to do it is think of, okay, well, here are the yellow ones. So I started with 20 and 2 are yellow, so the leftovers are not. Look at how much easier that math was to do than adding all these numbers up. So you could have did it either way. I would write both ways down because this one might be easier. You might like this way easier. Taking the 20 I have, taking away the 2 yellows. I'm covering it up with my finger, but of course you can't see that. If I cover up the 2 yellows, the rest would be 18. So 18 out of 20. Again, if this answer isn't on a multiple choice question, put it in your calculator. What does it reduce to? It reduces to 9 out of 10. All right, the last one's a really tricky. It makes you think, and I actually had to do some work. Drawing a color with more than 4 letters in its name. So I looked at each one of these and I said, well, okay, does this have more than 4 letters? No. Does this have more than 4 letters? No. Does this have more than 4 letters? Yep. Does this have more than 4? Yep. Does this have more than 4? Yep. Does this have more than 4? Yep. And now I'm going to add these guys up. Or, again, I could do the backwards thing. I could say, well, there's 20 total. Here are the 2 I don't want. So what's left over? But either way, same answer. 4 plus 2 plus 3 plus 1 will get you 10 out of 20. Again, if your answer is not here on a multiple choice test and you're like, oh no, I got it wrong. Well, maybe not. Did it reduce? Yes, it does reduce. It reduces to 1/2. Which again, we talked about changing this could be represented as a decimal. I could also represent this as a percent. So don't be concerned when your answer might not be there. Your answer could be in a different form. See how many different forms there could be? So don't get confused on a test, because I'm telling you right now, on your test, you will have answers that might not be the way you might get them. They might be as a reduced fraction. They might be as a decimal. They might be as a percent. So be aware of that. All right, moving on to another kind of type of question, and then we'll go back to theoretical probability in a moment. There are 25 students' names in a hat. I'm choosing 5 names. 3 are boys' names, 2 are girls' names. How many of the 25 names would you expect to be boys' names? So this is a predicting question. And one of the real main uses in real life of probabilities is to do predictions, like the weather. I'm predicting the weather. If it says it's going to rain 10% of the time, how many days would that be actually raining? Stuff like that. So what I'm going to do is I'm going to look at the situation that I have. So I have 25 names in a hat, but I don't really know too much about it. The only thing I know is if I picked 5 names, and 3 of them were boys. And again, visuals are always helpful. And 2 of them are girls. So this is the only situation I really kind of know about. And it says, how many out of the 25 names would I expect to be boys? So I am going to write my probability of it being a boy. What is the probability that I pick a boy out of this group? There are 3 boys out of 5 total. Now, here's where the prediction comes in. What I can do is I will then multiply my probability by the total number of people that I have. What this will allow me to do is predict how many boys are in my total group. So I am going to do, in your calculator, I want you to type it in, 3/5 times 25 and tell me what you get. All right, pause it if you need to. I'm going to go over it. All right, so when you do this, you get 15. So that means out of this group of 25 kids, 15 are going to be boys, which means I can do a little subtraction and figure this out. How many girls would there be? If 15 of these 25 kids are boys, what's the leftovers? What's left for girls? 10. Now, why does that make sense? Well, look at it. There's a little bit more in my small group. There's a little bit more boys than girls. In my big group, there should be then more boys than girls based on my prediction. So I'm doing a prediction. Based on this group, there should be more boys than girls in the bigger group, just like there are more boys than girls in my small group. Okay. The final section I want you to try by yourself is this using a number cube to determine the theoretical probability of an event. Again, this is based on what you know. Before I tell you anything about rolling a die, what do you know about a die? You know there are 6 sides to the die. You know there's a 1, a 2, a 3, a 4, a 5, a 6. You might even want to write some of that stuff down just so that you know, here are my options when I roll a die. So now I want you to roll these. And again, we talked about an even number already, so go to your notes page if you can't remember which ones are the even ones. And come back when you're ready to go over this. All right, welcome back. So rolling a 2. There's only 1 2 on my dice out of 6. That's it. Rolling a 5. Again, there's only 1 5 out of 6 options. An even number. My even numbers are 2, 4, 6. So those are 3 out of 6. And finally, rolling a number greater than 1. That's more of the reason why I wanted to write this. How many of these numbers are greater than 1? And I like to look at them to kind of see. And I even make my little check marks on it. Greater than 1. So 1 is not greater than 1. It's equal. But 2 is, 3 is, 4 is, 5 is, 6 is. These are all greater than 1. So there are 5 numbers out of 6 that are greater than 1. If there's a little bit of time left, here's what I want you to do. I want you to make these into decimals and into percents, just so that you're aware. Actually, reduce the fraction first. In some of these, they may reduce, in others, they might not. Reduce the fraction, then make it into a decimal and make it into a percent. Pause the video, and when you come back, I'll go over it. If there's not time, actually, I don't have time to do it. So I'm going to let you do it. Go over the answers. check your answers with each other, check them with the sub, and I hope you guys have a great day. Again, today's topic, experimental and theoretical probability. Theoretical is based on a situation that's happening one time. An experimental probability is based on an experiment that was done and you have results for, and you have to base your answers on the experiment that was done. I can't wait to see you guys back on Monday. Hope you have a great weekend. Remember, homework number 68 is due on Tuesday, and I will see you then. Bye, guys.